Hello. Hi guys, good morning. Welcome back to my video. Ki hal chal? I hope you're doing good. In this, we're gonna see a problem. Construct smallest number from di string. It simply says that you are given a pattern which is built up of d or I. And what you have to do is you have to build up a string num of length n plus 1, which means one higher length, and that is created by following a condition. What the condition is? Condition is that if the num consists of digits from 1 to 9, obviously, and again, with this fact, you can easily figure out that if the digits are only from 1 to 9 and they are occurring at most once each digit, which means every digit will be unique. And in worst case, I can have 9 digits, which means the length itself of pattern will be 8. And that also they have given that the length of pattern is 8. That's the one observation which we figured out from the question itself. Okay. The main part is that if the pattern is I, my number should be in an increasing fashion. If that is t, it should be in a decreasing fashion. And I have to return lexicographically smallest possible string. I have told you a lot of time what lexicographically smallest is, but just as a reiterating, if I have 1, 2, so you can see this 1 is occurring first and is smaller than, let's say, 3. So this is lexicographically larger, lexicographically larger, or even I have this, like this is lexicographically larger than this one. So whenever I compare two things, I start comparing with their first occurrences, and whoever is smaller, that is actually my winner. Cool. Now for this, obviously you will see that these are example given. I'll take a different example. That example will cover all the corresponding cases and for the follow-ups as well. Now with this, I can easily see one very interesting fact. Oh, the value is pretty less. In that case, I can try for all the possibilities, which means obviously I will try for recursion, and I have to figure out a good pattern, or a great pattern which is lexicographically, see this pattern which is lexicographically as small as possible, which means I will try for recursion, and maybe if required I will try for backtracking. So I will highly recommend, please come to crash course, and you must have studied the backtracking crash course at least. If not, then you can just try in the practice problem sheet, DSA sheet, you can come on and do the corresponding questions for backtracking as well. Again, there are a lot of numerous questions. Now, coming on back, we realize that, okay, let's try for backtracking itself. Okay, let's figure out. So I have these options. I know this is my input string. I have written the same string here. Let's try. Firstly, I will place a 1. That's the option I have. Okay, I placed a 1. Then I will try to place something. But here is D. So I have to place something which is lesser than 1. Can I place it? Oh, no. In that case, okay, I have to correct it. Okay, try to place next number available, 2. If I try to place a 2, here I have 1. Again, I will come on and I'll realize, okay, I have a 1, I will place a 1. Then again, I have a D. The thing which is not used so far is all these numbers. But I want to place something smaller than this 1. Can I place it? Because I found the first number which is not used is 3, and that is itself, not lesser than 1. Okay, this is also screwed up. No worries. Let's revert back. When we say revert back, this is what? This is nothing but a backtracking. Again, I'll highly recommend, please go and, let's say if I refresh this, please go and watch this backtracking crash course just to understand what the backtracking is. Now, we will put up 3 here. Then I will get, okay, 3 is used. Then I will try to put up a 1, because obviously this is the first thing which is not yet used. Can I put up a 1? Yes, I can. Okay, I'll put up a 1. Then I will try to again put a D. Oh, can I put a D? No, I cannot, because there is nothing which I can put smaller than 1. Okay, which means that reverted. Then next available. Okay, it is 2. Put up a 2. Can I put it? Yes. Okay, next available, which is 1. Yes, I can put it. Okay, next is I, and next available is 4. Can I put it? Yes, I can. Okay, put a 4. Next is D, which means any number smaller than 4. But I see there is nothing available. Okay, which means revert back. Okay, undo. So you see that I have some data structure which will say used, which will tell me what all numbers are used. Because the numbers which are not used, I can pick only those numbers, and I have to make sure that whenever I'm backtracking, I will put them number as unused again. Okay, coming on, we tried for 4 earlier. Now we'll try for 5. Okay, 5. Now, can I put a D here? Yes, I can put a D. 4. Here. Can I put another D? No, I cannot. Now, in that case, oh, I cannot put up another D. What to do? Oh, no worries. Go back. If I go back, I will try to go back. I'll try to put another number, 6. Great. Okay. Then what? Then these are already gone back. Now I have another D. I'll try to put up a 4. Put up a 4. Can I work out? Another D came up. I cannot. Okay, no worries. Put up a 5. Can I work out now? Maybe. Because we will then put up a 4 here. Okay. Then it is going good. Now I have next is I. Okay. Next is I. Next is I. If it is, then I will put up a simple 7. Okay, then another D, I don't have anything. In that case, simply go back, try for the next possibility, which is 8. Now, if I put up a 8, now I have another number for D as 7. Can I put up? Yes. Okay, but for another D, I only have possibility of 9. Can I put up? No. Okay, no worries. Go back. Go back. Now, I'll even put up a 8 here. Now I'll put up a 9 here. Next number, I will put up a 7 because that's the first possibility which is, available for me. Then can I put up another number here? No, I cannot. Okay, no worries. Go back. Now let's put up a 8. Okay, I put up a 8 and then I put up a 7. So you see that I'm trying to put up the possibilities from the smallest to largest, and if I am screwing up at anywhere, I'm coming on back and trying with the next value which I can place. That's how I can simply go about stuff. Okay, so what did you realize from this? It's a simple backtracking. Again, as I mentioned, that yesterday's question which we saw, you can come on to yesterday's question. We can come on to the backtracking, medium. This was the yesterday's question, which is exactly same as what we are seeing today. It's just that, what is the complexity for this? At every place, I have, in worst case, 9 locations. For the first location, I have 9 possibilities. For the next location, I have 8 possibilities. For the next, I have 7, 6, 5, and so on and so forth possibilities. Ultimately, I have 9 factorial number of, again, and if you don't know, like 9 factorial is around, again, it's under 1e6, so we are good with that term, with that thing, and that's how we can simply solve it. Cool, let's see that. The code is pretty straightforward and simple as what we saw yesterday as well. That firstly, I will have an unordered set which is used. Again, you can take a vector as well because the size is pretty small, but again, I will pass everything by reference. I'll pass everything by reference, so it will not matter as such that if I take a vector or an unordered set. Now I will have a backtrack function which will have a pattern, again passing by reference, which will have the current index I am at. It will have the current string which I am building right now. This is the answer string. This is my used vector, and my corresponding result. Again, that's also, this specific result which I have is also being built up. Again, this result is my final answer which I wanted to return, because I told you that I'm going from smallest digit to the largest digit. So any first occurrence which is possible or which reaches the end satisfying my entire pattern will be my answer, because I'm trying to build up from smallest to largest. So with that fashion, any first occurrence of my answer will be my final answer itself, because I'm building up in that fashion. Now, coming on, the code is exactly same as yesterday as well. That again, I am skipping the recursive piece of bit and directly jumping to the backtracking piece of bit, because yesterday, in very thoroughly, very deep in this problem, letter tiles responsibilities, you can come on to tech blocks, letter tile responsibilities, we went very thoroughly and deep into the entire backtracking, entire recursion, entire again backtracking, optimization, everything. So yeah, that's the reason we skipped it. Again, before we go on further, please let's have a like target of 100 likes, if you can please do it. Now coming on back, we will try for all the digits from 1 to 9. I will check if that digit is used, please continue. If not, then if my current string answer which I am building, if it is empty, then obviously I will have to put up some digit. But if it is not empty, which means I already have something, then I will check that if it is I, then make sure that if the current digit the current digit which I'm about to place, technically it should be more than the already placed in the end. So this represents, in the string which I am building, the current string which I am building, this is the end of it. If it is, like, I have to make something of this sort, that the D should be larger than my last digit. But if the last digit itself is larger than or equal to D, then I'm screwed up. I cannot put up this digit. I should try for a next digit. Okay. And if not, and then if it is D, like it is decreasing, which means that it should be something of this sort. So if it is vice versa, which means this current digit is less than equal to my digit, then it is a issue. So this is a happy case, but this is a issue case. So in the issue cases, I have to continue and try for the next digit. If not, if it's a happy case, then simply put up that digit, append that digit inside your string. Make sure that now it is used, and then call your backtrack function and say that okay, from the next index onwards with this current string and this used, and again result I will build up in the very end. You can declare this as global as well. Ultimately call this. Now I have simply made a if condition, just that as soon as it reaches the end, I will simply return true. This will make sure that it doesn't try for any other possibilities, and ultimately return true from here. Now the backtracking logic only, again, this portion is the entire portion of recursion. The backtracking simply says that okay, simply erase the used as you're coming back, simply erase the last digit as you're coming back. Again, I will not reiterate, but this is exactly what we did, a lot more in deep in recursion and backtracking in this problem. So you can just check out this one. Now, this is how we can go about it. And again, I told you the complexity. At every point, I have 9 options to place. So for the first point, I have 9 options. For the next point, because one is already used, I will have 8 options, and so on and so forth. I will have ultimately n factorial number of possibilities which can come up. Space will be the recursive depth, which will be O of n, and that's how I can leverage my time and space complexity. Will it work? Yes, it will work. Will it pass? Yes, it will pass. Should I do it? Maybe. Because you will see that now we can see a bit of more optimization. Again, just a FYI, people you will see for this problem will never discuss this approach, although this is the most intuitive based on the constraints as well. Now, can you improvise this much more further in this terms only? Yes, because right now you will see it's in factorial terms. You can also optimize that to exponential ones. Again, is it required? Not necessarily, because if you look very closely to the actual answer, you will realize one very interesting fact. Did you see something that, okay, I have this thing, DDI, then you will see something of this sort. Then you will see DDI, then something of this sort. Then you see DD, okay, something of this sort. Like, did you, again, this is not only I'm saying while I'm building up the answer, but this thing, while I was dry running itself in the recursion, you must have realized one thing, that while, okay, I had DDI, so technically in the very starting phase, it just mentioned that I want 2 consecutive Ds, right? I want 2 consecutive Ds. So obviously, whenever I say 2 consecutive Ds, I want 3 digits. So if I want 3 digits and 2 consecutive Ds in the very beginning, obviously I will have to take these, right, and reverse them and put up as 321, right? Now forget about this increase, let's say for now, but obviously it's an increase. I will put up some higher value, which means I will have to put up some higher value. I will put up some higher value. But the interesting fact is I have a DD. Okay. If I have a DD, then I will again say, okay, this should be decreasing. This should be decreasing. Obviously, I will have to place something here, which is, another comp. So this is another combo which will start up, which is DD. Now for that, I will say, okay, the thing should decrease, the thing should decrease. And with that, I will say, okay, I have 4, 5, 6, 7, 8. Can I take 4, 5 only? Can I take that? So you will say, okay, if I take 4, 5, then obviously I will have 5, 4. Then this is just increase and this is just one decrease. Technically, I want 2 decreases. Okay, I will have to take the length of 3. In that case, I will simply again reverse it. I'll get 6, 5, 4, right? And this will handle decrease, decrease, twice decrease, it will handle. Okay, great. Again, in the last, I again had a DD, which means obviously 2D, I need 3 numbers. I will again take them, reverse them, and put it back 9, 8, 7. And this is how I can form it. So you realize that technically, if I have this input string, all these numbers, as I'm getting some D's, I'm taking those numbers, and then reversing them and putting them back in my string. Now, which data structure will be very easy for you to reverse things? If I gave you something, let's say, if I gave you that, okay, your name is Aryan, and I ask you, you have to reverse it. You will say, Aryan, I can simply use a stack. But then if I ask you that, okay, you have to reverse, maybe the first half and the next half, then again you can apply string operations. But if I give you reversal at every bit, let's say mi and then tt and then al, I ask you, okay, reverse at every interval, and that interval can be not even, then how you can do that? Obviously, stack gives you operation of first in, like last in first out, which means that if I have anything a r y a n, if I start putting up a, then r, then y, then a, then n, if I start getting out things from the stack, which is n, then a, then y, then r, and then a. So that's how I can actually get reversal of anything which I want. And again, this will actually help us also in terms of if I want to do piecewise reversal of things. Now, let's come on back and let's see how we can solve the same problem. Cool. Where's the code? Yeah. Okay. Where it is gone? Yes, okay. Now we realize that let's try to do the same thing. So again, I know that I have to go from what number to what number. I will go from int I is equals to, again, I have to put up some numbers, inside my stack. I can go from I equals to 1 to pattern dot size plus 1, and then I plus plus. That's also how I can go. Or I can also go from 0 to pattern dot size, ultimately saying if I have size as 8, I will go on to 9 digits from 1 to 9. So if it is 0, you have to make sure that in your, like, obviously you will take a corresponding stack, stack, and let's name it as num stack, number stack. So in that num stack, I will just make sure that I will push up this I plus 1 rather than I. Again, if you take from 1 to, pattern plus 1, you can just put up I itself. That's completely fine and totally up to you. Now comes the interesting part, that how we can solve it. Let's try to do a dry run here as well. Now I have this num stack, I have this num stack. Now let's put up all these numbers which I have. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8. Technically, you will see that these are the indexes which I will iterate on. And if I am on 0, I will push up a 1 inside my stack. Again, if you want, you can also take the I plus 1 values as 1 to 9, which means, okay, you can just simply push up values from 1 to 9. Now, firstly, I will just start pushing up things. Okay, I have 1, I will push up there. Okay, then I will have to check, do I have a I so far? No, which means, okay, keep on pushing things. Okay, I will push up for D. No worries. Okay, for D, I will push up because you saw that grouping was done for D, and as soon as I came up, I kind of reversed things. So I will have 1. Okay, already done. Then I got a first character which is D. As I was going ahead, I realized, okay, I have a D, which means I haven't seen a pattern of I as this thing. So okay, let's put up a 2. Okay, I'll put up a 2. Now you might say, Aryan, why were you checking this? It is only because you see that it will help me to iterate on my pattern easily. Help me to iterate, because iteration on the pattern will be from indexes from 0. That is the reason I actually took up from 0 to 8, and thus was putting up a plus 1, a I plus 1 inside my num stack. Okay, coming on back, that okay, we put up a 1, then we put up a 2. We put up a 2 here. Okay, when we say put up a 2, which means we were at the index correspondingly index 0, and this is index 0, 1, 2, 3, 4, 5, 6, and 7. Now I put up a 1, I put up a 2, then I landed at the corresponding index 2, and firstly I will put up it, which means inside my stack. Then I realized, okay, bro, it is a I. Oh, if it is a I, which means I have to reverse this thing. So I will take this entire thing out and I will reverse it, which means I will get this out from my stack and put it in my result. So in my result, I will say 3, 2, 1. Okay, let's continue. I received a D. So you saw that as soon as I came up, I reversed things. Now D came up. Okay, I will put up a 3. Then another character 4. Okay, I'll put up a, sorry, here should be 4, and then because of this value 4, it should be 5, because this is index iteration, and just because of that I will putting up actual numbers inside my stack. Now again, at the next index I will put up a 6, And because it's a I now, I again have to reverse things. I'll get this out and reverse it and put it here. 654. Okay, this is empty now. Then next again iterate it. Okay, I have this. Okay, I'll put up a 7. Then I have this. I will put up a 8. Then in the last, you will see your actual for loop went on to digits primarily. That is the reason in the last you will also go on to index 8, which is not there technically, which means that you will land onto here. You will put up inside your stack a value 9, but then you realize, okay, it is empty. So you cannot access the pattern. That's a one thing, which means that you will have to put up a condition that, if you have reached the end, which means your I has reached the pattern dot size. In that case, it ultimately indicates that the entire thing is finished, or it can be also assumed as one more eyes. It can be also assumed as one more eyes. Make sure to reverse this entire thing and put it back onto your result. 987. So I realized that if it's a I or if it's a end, I will have to get things out into from my stack and put it in my answer. And that's how I can achieve it. Cool. Let's see the code. It's exactly same as I told that I will have a stack. And then I will keep on going on to from 0 to the pattern dot size. So in this case, it was from 0, 1, 2, 3, 4, 5, 6, 7, 8. Now I will push up I plus 1 because the number should be from 1 to 9. Then I will check if it's a I. That is the condition as I showed you. If it's a I, which means these locations. Or I also said that if I have reached the end, because in that case, there will be no I. So I have to also have that condition. If it's a I, or if it's, if it's the end or if it's the I, make sure that you reverse things. How will you reverse things? Just empty out the stack. So I'll empty out the stack and put things into my result by converting them to a string. And each digit will be converted to a string and will be added to a result, and ultimately making sure that you pop it and keep on repeating until the stack becomes empty. Thus that piece of code will be reversed and will be added here as a reversal form. And ultimately I will repeat this for every of the I or end and ultimately getting my final result as an answer. Because you are going on to each and every character at most twice, that is the reason time will be O of n only, and because you're using stack, the space will also be O of n. Cool. I hope you guys got it. Again, I try to discuss backtracking approach as well, because I know no one else will discuss that, because people will directly jump onto this approach of stack. Although it's most optimized, but still you will see based on the constraints and based on the standardized problem statement, it seems more of a backtracking approach, backtracking question rather than a stack question. Bye bye, take care. I hope you guys got it. Make sure that you do check out, again, the article will come up here, and make sure that you do at least the crash course of backtracking. Again, it's just one video, full of multiple questions which will cover everything. Bye bye, take care. Please make sure that we complete the light target.